Thanks. I mean, I couldn't help but notice the room just emptied. I'm not sure if that's a reflection of my talk or how good the other talk was, so, but we'll go with that.
No, I think it's because getting full.
Well,
It's our fault.
can't blame me this time. I've only just got here. Cool. So at Express, we've always been very strong on privacy and transparency, and more recently, that's meant we've started looking into and digging into open hardware. Now, we've looked at this in the past, but it's only more recently that we've been able to really kind of get to grips with this. And I think it was only a few weeks ago that we finally completed the paperwork, and we joined RISC-V International as a strategic member. So, we've heard a lot about RISC-V being very open. We've heard about, for example, the framework that it's modular, it's easy and repairable. What if you take that one step further? What if you could verify every layer of your stack? And by that I mean all the way from the silicon to the software itself. And at Express, our transparency philosophy is pretty simple. In order to get transparency or provable transparency, you need to have a number of things. And in this case, to build trust and to ensure that we actually have a platform that people want to use and that we can demonstrate that we do what we say we do, we need to be transparent. This isn't as common as we might hope, but with the work that we're doing, for example, Lightway, it's our main VPN protocol. It's open source. Anybody can download it. It's had 2 independent security audits on the new Rust code base. The previous C version also has full security audits. So open protocols enable verification, like they're there for anyone to check. And it's the open infrastructure that enables trust. So what exactly does open hardware enable? And the answer is really new possibilities. There's a lot of interesting stuff that you can do once you can actually get hold of the hardware itself. And so this is just talking a bit about what we've come across so far. We're pretty early into the journey, but I thought it was still interesting to share. So for us, so Lightweight, as I mentioned, it's fully audited, it's open source, anyone can get hold of it. Trusted Server is our in-RAM operating system. Basically, we deploy it directly to memory. It never touches disk. If a server is unplugged from the wall, everything's gone. You plug it back in, it's exactly the same as when the data center handed it to us. We don't install anything on the boxes. We never touch the disks. That's in progress of being open sourced. And our next frontier really is the hardware. That's where we're headed next. And once we do that, we complete the transparency stack. So right now, applications, protocols, operating system, all available. Firmware, not so much. Those are all black blobs in most cases. And the hardware itself, still not there yet. That's still undecided. And that's something we're hoping that RISC-V will help us with. So why does it matter? The challenge is interesting. Off-the-shelf hardware, it's designed to a price point. It's designed for a general user. It's not designed for privacy. That was never one of the considerations. Many have black box components, which means the capabilities of those things are unknown. You have the capabilities that they claim are provided, but in reality, you have no way of knowing if that's true or not. I'm not saying that as a conspiracy theory. There's probably nothing in there, but you have no way of knowing. Just trust us. I'm sure it's fine. Never heard that one before. There's also limited flexibility, like one size fits none. This usually means that if you ever, in my experience, whenever I've bought a new machine, a number of times I've tried to do it properly. I've been good. I want to save money. I'm going to buy the right machine for me. I'm going to get the right amount of memory. I'm going to get the right CPU. I put all that effort in. I buy the machine, and within a week, it's not good enough for what I need. And I should have bought the bigger one after all. And now I have no choice but to either live with this mistake and be miserable for the next 5 years, or go and buy the one I was going to buy originally. And this is one of the problems. You really can't tailor things too much to your needs. This used to be true for laptops 15 plus years ago, where if you wanted more memory, you could have it, but the hard disk was smaller. Get a bigger hard disk, less memory. Like, why? Who knows? But that was what it was like. We have the AI privacy dilemma. I'm sure a lot of you have been to the AI talks here, and you've used it all yourselves. If you use any of the cloud AIs, they're extremely powerful. They're extremely quick. Private, not so much. And it was really only after a lot of people complained and businesses refused to use it that the big AI companies even started putting policies in place to say, okay, we promise we're not going to, basically steal your data and train on it, which is important because often that data turns up in other people's answers, which is not really what you want. Now, despite how powerful this stuff is, a lot of people, have questions. Oh yeah, AI would be great for this, but there is no way in hell I'm typing that into ChatGPT, right? I'm not putting that into Claude. I'm just not going to do that. But that's okay because we have local AI and it's private. But that's pretty much where the good bits end. Even if you get one of the larger models, like for example DeepSeek, it doesn't compare very well when you run it locally to what you can get hosted. And obviously there's very simple reasons for that. It's just they're running on better hardware, it's more optimized, they access more resources, and they have the benefits of scale that when you run a local machine you don't. And of course, it's usually slower on your machine because you don't have a massive data center in your pocket. And this is something that custom hardware could help bridge. If you had something that was just doing this one piece that you need, and only focusing on that part, then there's a lot of potential wins that you can get out of it. It also extends zero trust. I mean, historically, it's always been don't trust the network. With SaaS and things, now it's don't trust the service. Potentially in the future, then we're looking at trust the hardware. Now, this has been tried many times. I think the one that got close to it was open power. That's mostly in larger servers. It didn't really go very far. But it was never something that you'd expect to see in a desktop, let alone a laptop. And forget mobile, that's never happening. But if you want to trust the hardware, you need to be able to see what it's doing. Now, this is a bit like open source. The fact is you can go and check. I mean, it doesn't mean you will, but you could if you wanted to. And everybody kind of hopes somebody will go and check it. But it's much harder to hide things and to be, to be non-transparent if anybody can go and look at what you've done. It also changes the dynamics of how you do interactions, right? So for example, if you look at, again, Framework's a great example of that. Their stuff is all open, right? You can go look at it, you can discuss it, you can criticize it, you can do, you have these conversations, but it's all there. And the beauty of that is, if you're doing a great job, that shows up too. So it cuts both ways. So what are we learning from our initial run into this particular field? Well, RISC-V, it's not just open, it's customizable. Now, this is of interest to us because we have a lot of things that we specifically need for our use case, but we don't need anything else on it. So we saw this, for example, when AI first started getting big. People started buying, basically, big, heavy-duty GPUs. And then it wasn't long before you could get a GPU without the actual graphics adapter on the back of it because no one was using it for graphics, they were just using the cores. But in those cases, you got the adapters because that's what you got. There was no way of getting rid of it. You just had to work what you were given. And that adds cost, it adds complexity. So if you only want one tiny piece, you don't have to bring in the whole shop. And that's something that RISC-V will let you do. It also, again, goes in both directions. You can add the things that you care about, and you can remove the things you don't. And you can optimize for your use case. And this is pretty much purpose-built for privacy, right? You can customize this whichever way you want. There are open source GPU cores you can already download and stick on FPGA. There's a great device created by Bunny out of Singapore where he's created a RISC-V processor that runs on an FPGA inside the device. Yeah, I've just blanked on the name of it as well, but it's a lovely little device. But he's got the code so that you can go and verify that the CPU that you're running is actually the code you think it is. And so you can be assured that your processor actually is what's claimed, and you can go look at the code and you can see how your processor is built. And of course, you can change and fiddle with it if you want. Yeah, the precursor, yeah. So it's a really cool device. It even, in the backdrop, adds wiggly lines to help make sure that nobody can do inference and stuff on the screen itself, which is kind of neat, if you've ever come across the Tempest. So what did we discover when we were doing this? Well, things are moving really, really fast. When I first started looking into this, there wasn't a huge amount, and I started collecting little RISC-V boards. I'm going to have to kind of get out of that habit now because, well, one, there's too many of them, and two, they're getting more expensive and more powerful. So it used to be just a cheap thing you could pick up. Now they're getting a bit more expensive. Support for these things is massively expanding. Previously, when I first started playing with this, there was a lot of work to even get the thing to boot or to do anything useful. But today, that's completely changed. Now, for example, if you run the Orange Pi V2, it runs Ubuntu out of the box and it works beautifully. Everything works. Performance, not so great. But again, like the first laptop I had was so slow that you really couldn't use it. It worked perfectly, but it was just too slow for daily use. But the fact that it actually booted at all was pretty cool. A year later, now it's completely usable. The one that's just come out, yes, it's not as good as my x86 laptop, but now it doesn't want, I don't feel the need to throw it out of a window constantly, most of the time. Right? And this is in like a space of like 2 short years. We've gone from an unusable prototype to, I could actually use this, as a daily device. I can actually develop on this. In 2 years, that is huge. Hardware in particular doesn't normally move that fast. And so to see this massive step forward and then have this huge support behind it, it's huge. It's still early days. There's still limited options. Standards are evolving. But that's part and parcel for the speed that we're moving at. So we're building and testing on RISC-V. We're playing with a few different proof of concepts, particularly like VPN acceleration and stuff like that. Lightweight works in a very particular way. And so if we can get that on chip, or get that closer into silicon, then we can potentially speed up the VPN. We can lower the overhead. We can use less battery and all that sort of stuff. And of course, it has custom extensions. So if we do want to do interesting things, we can effectively add that to the chip itself. So why are we really excited about this? I mean, for example, if we build a VPN router with this thing, where every component is auditable, the hardware acceleration actually works, and it's transparent, and it doesn't need a special kernel from 30 years ago, isn't using an old SDK, is modern and fun to work with, where there's no hidden management engines, and you control effectively the entire stack, then you can have true end-to-end transparency, and from that you can build trust and you can build your privacy. Privacy preserving AI at the edge. Again, imagine you have this, as it says, a router device, and you use it for get to your storage. Imagine if you could do limited AI workloads. What if you could tag images, or create subtitles, or do translations for the videos that you download? All these background tasks that don't need super performance real-time response, but can sit away happily working on this. You don't need it to be instant, but now it's on your device. It's running on a chip that you have the specs for, running on hardware that's vetted and open. You basically get all the power of AI, but you also get the privacy protection. Now, it's never going to be quite as good as what you're going to get in the cloud for fairly obvious reasons, but you just need it to be good enough. You need it to hit your use case. And there's some very compelling things that we're already seeing you can do with this. Trusted Server 2. So right now, for example, as I mentioned, all of our servers, they run on RAM already. All of our images are cryptographically signed. Every server runs exactly the same image. There's no difference between any of them. And we have a lot of transparency and trust stuff kind of built into this. But it's only from the OS up. We can't work down. And what would be really cool is if we could have servers where we actually control the whole stack, where we can validate the server is the server we think it is. We can validate it's running the hardware we think it's running. We can validate that no one's started plugging things in and are playing around with the thing, which is, obviously for our use case, extremely important. But this is a step forward that with current stuff like the x86, there's never any way to kind of prove this. You can do some stuff like, say, SGX and stuff, but then again, you're still trusting that the CPU implements it correctly. Spoiler alert, it doesn't. It's been broken many times. We need other options, basically. So challenges, opportunities. These are, I'll go through these quite quickly. I mean, as I mentioned, it's not yet up to speed, quite literally. Tools Live is still developing. Limited vendors and options, and new skills and knowledge are required. However, it's realistically only a few years that this level of performance and hardware has become available, which is still insane to me. I remember waiting, literally a decade for previous, Open Power, for example, is literally 5-10 years of work. We've gone from something that's unusable to almost something you could put server grade in a very short space of time. So this is expected. If we didn't have this, then it would show that no one actually cares about it and no one's actually getting involved, which would be a much bigger problem. Some core opportunities, though. Freedom to innovate. We don't have to be constrained by legacy designs. You can basically do whatever you want. And again, with access to things like AI, with access to things like YouTube, with online stuff, the communities, you really can start building the stuff yourself. You can take a basic chip design, you can synthesize it onto an FPGA, you can make tweaks and actually play with it. And if you can get a design working on FPGA, then it's not too hard to get that to something you could take to a foundry. You probably shouldn't, but you could do that if you wanted to. The community is amazing. Everyone's kind of interested in this stuff, has rallied around it surprisingly quickly. It's just a good idea. And it's relatively rare that these things turn out. Usually there's always something for someone in it, and someone somewhere is kind of getting screwed over. In this case, everybody wins. There's no downside to this. You still have the first mover advantage. We're seeing people creating this and working with this, and we're already seeing companies kind of probing around to see who knows a bit about RISC-V, who's doing stuff. Right? I'm already seeing, because I mentioned RISC-V, I'm always seeing people like scouting through my LinkedIn profile, just because I put that sort of stuff on there. And differentiation. If you have your own chips and you're doing your own thing, that's something your competitors can't match, right? They don't, unless they take your chip and they run your chip, which honestly would be amazing. If our competitors want to run our stack, please feel free. That benefits us. It benefits their users because we feel we have the better stack, 'cause of course we do. And truth is, I'm pretty sure we do. Not biased at all. So from my point of view, it's a win. They win, we win, everybody gets something better. And if they improve it, well, we'll happily take that too, right? So this is a very interesting dynamic. It's very rare that you can actually both have something that has no differentiation because everybody can use it, but that itself is your differentiation, that everyone can use your tech and benefit. Right now this is very rough, but I reckon prototypes 1 or 2 years for some of the serious stuff that we're talking about. Products 3 to 5, and then starting seeing real standardization. Now we're already seeing this, the early stages of it. The framework itself is actually in place to make this happen. It's going to take a few iterations before we do it. And again, we're talking about hardware designs, chip designs. 5 years sounds like a long time, but bearing in mind ARM and Intel come from the 80s, and how long it took them to get anywhere near what we have today, and you realize that RISC-V is actually moving insanely quick. So how to start exploring? I won't cover this too much because you guys probably already know this stuff, but just pick up a board. If you go to AliExpress, for example, there's a whole ton of stuff. It's really cheap. If you don't like buying from them, you can buy from effectively a reseller. But you can get boards from just a few dollars basically, all the way up to the heavy duty boards like the Orange Pi if you want. For porting your software, most things do just work. Not everything, unfortunately, but a lot of it will just happen. And work with the community. There's a lot of stuff out there that, particularly that we've come across, where someone else has hit the landmine before we have and has reported back do not step here. Beware. And start small. Have a play with it. It doesn't have to be perfect first time. Just get some experience to get used to it, and then give that feedback. It's surprising how just a small amount of feedback, a one line in a blog, or a reply to something on Stack Overflow, can really save someone else potentially days of work. And it's better if we're together. It's not a solo journey. I mean, the hardware guys, they need use cases. Software developers need the hardware, and everybody else needs solutions. Basically, no surprise there. Open source community, we all need each other, and it's just better if we work together. Everybody brings their own abilities to this, and we all walk away with something. The sum is greater. The whole is greater than the sum of its parts. So why does it all matter? For us, obviously, it's VPNs, but it's about building infrastructure that we can trust, and I mean that term in a very generic sense. Wherever you use this, whether it's in cars, whether it's in machinery, whether it's in technology, it's all about that. It's also about having options beyond big tech, right? Right now, this is kind of concentrated into 2 or 3 very, very large companies, and we've all seen with the complex geopolitical stuff going on, things that we assumed would just be the way things always were, have suddenly not been the way they always were, and that's left entire industries and countries looking for alternatives, and there aren't any because nobody thought this would ever be a problem. So having options is always important. You can innovate without permission. You can just do what you want to do. And if it works, it's great. If it doesn't work, well, no problem. You can always try again. And yeah, I think it's the future of digital privacy, the ability to know that what you think you're running is actually what you're running. And to put this into context, I mean, Red Hat did a very nice promo video for this back in 2005, something like that, called Truth Happens. It's worth a watch if you haven't seen it. But it's really interesting how Linux went from, this is just a hobby, to in 2000, which is when I got my first Red Hat Server Engineer qualification, which I realized when I worked that out was about nearly a quarter of a century ago, which is quite disturbing. But back then it was very much a punt. It was a guess. Right? Nobody was deploying Linux en masse. There were no smartphones. There was no Android. Right? It was servers. That was really it. A few of us had laptops, but we owned Linux on laptops was not such a great experience. In 2010, you know, Linux was definitely in a very, very strong position. But it was still a case of, yeah, it's great for these things, but you know, if you want to do this, you still need, you know, this other stuff. And yeah, 2025, there's a very rare reason why you'd ever boot up a Windows server. So I think RISC-V is on the same path. I imagine that we'll see the same sorts of thing, like, yeah, this is a toy, no one's going to use it. Oh crap, people are using it, but it's probably not going any further, it's just luck. And then by the time you actually realize, no, it's a thing, you're now 10 years behind and everyone else is ahead. You can see this, for example, with NVIDIA's recent announcement for RISC-V support. And that's really cool, but in the long term, I don't think it means anything right now. But they're making the bet that, you know, if this thing gets big in 5, 10, 15 years, we want to be there. We don't want to be the ones that thought it's just a toy and it turns out it's going to change the world. Because nobody wants to be left behind. So even if people are only getting involved just to make sure that they don't get left behind, and possibly because they're trying to make sure that they don't get left behind, it actually drives the thing forward, yeah, it's all good. So yeah, it's not the whole solution, but it's a big piece. Combine that with open protocols, combine that with open software, bit of engineering, bit of user education. Yeah, you can build yourself your digital future. And so yeah, let's discuss. I mean, if you're interested in reaching out, I've got my LinkedIn there. I think I've got still got 5 minutes left.